Okay, maybe we can start today. I welcome everybody to the server project track. I am Siamak Tavalai, Microsoft. I'm a co-chair of the server project. With me here is John Stewie.
Welcome, everyone. Looks like we're getting a slow start, a little bit different out there today than yesterday, but we should have a good track today going.
Right, we have a very good program. As part of the server project, what we do normally is review contributions that people bring to OCP for server projects. We normally have a process for 3-step contributions. Specification contributions are basically a baseline for other things to come. Based on base specifications, other companies, other people will develop designs that follow the base specification. And then the same company or another company might provide a product that meets that design.
Yep, and our project meets the fourth Wednesday of every month. www.opencompute.org/wiki/server. You can look up the agenda we have each month. There's the recording of all the calls and the mailing list you can sign up for to be on the invite for the next call.
Right. Besides projects, once in a while we also provide technology updates. A couple of sessions today are around that part. For example, the following session is going to be on PCIe and challenges that we might have for PCIe Gen 4 and Gen 5.
Yep. That invite Richard Solomon up to the stage.
Okay. Thanks, guys. Thanks for having me here, dragging all these fine people out in the dark of the night. Yes, I'm reliably informed that 8 a.m. is still the middle of the night in California. You don't have to sit way out on the side. It's okay to come in close. I haven't bitten anybody yet today. Oh wait, Olga says that means I'm due. All right, sorry. So today I want to talk to you a bit about PCI Express. I'll give you some of the background on the standards body itself, the spec, where we are. Obviously all this is pretty relevant to OCP since PCI Express forms kind of the backbone of the I/O that folks are using throughout the OCP ecosystem. First, let me talk to you about PCI-SIG itself. We are a member organization. Membership is open to anyone. We've got everything from giant multinationals out to the 2 guys in a workstation. Everyone can join. Everyone gets equal rights in the organization. There's a lot of standards you see these days. If you want to actually contribute to the specification, you got to pay more money. If you want to get the draft specifications, you got to pay more money. PCI-SIG is very open. We allow everybody to have access to everything. We're governed by a board of directors, 9 different folks. Each of the board members is actually serving as an individual. So we're all employed by member companies of PCI-SIG, but when we serve on the board, we act as individuals. Another thing about PCI Express is the breadth of the membership that we have. Actually, this slide's a little bit out of date. We're over 800 members, and our membership is increasing. Over the last few years, we've seen kind of a membership decline with all the mergers and acquisitions that were going on. But today, we're actually seeing an upturn where membership is growing. And that's driven really by the expansion of PCI Express into a lot of places people didn't expect to see it. Places like artificial intelligence, automotive. I'll talk a moment about the different market segments where PCI Express is found. And all those new companies doing new and interesting things with PCI Express are driving a growth in membership and driving a growth in use of the spec. Actually, I was just talking to one of the other speakers before the session got started about how PCI Express can be used as a chip-to-chip interconnect. So you don't even necessarily have to have the traditional host and device model in place to find places that PCI Express works well. Now, the specification has followed a path over many, many years. You can tell by the gray hair that I've been doing it for way too long. Back in 1992, when we first started with the parallel PCI interface, and evolving all the way up now through 2019 with the release of PCI Express 5.0. If you'll notice on the graph, this laser doesn't work very well on these screens, but there's kind of the purple path showing where the PCI Express spec went, and the blue arc showing where the industry used bandwidth. So kind of an adoption on the blue curve, introduction on the purple curve. Yes, this is my mea culpa slide as I point out that we understand PCI Express 4.0 was quite late. If you ignore that data point, which I'd really, really like you to do, if you just ignore that data point and look at the curve fitting, you'll notice that PCI Express 5.0 gets us back on track. And that segues nicely into kind of the market segments, the places that we've had PCI Express. Traditionally, when you thought about PCI Express, you thought about the kind of the cloud ecosystem, the server space, sort of the traditional data center. I talked a little bit before about how we're seeing PCI Express moving into places like automotive, artificial intelligence. Actually, I'm kind of not a huge fan of the term artificial intelligence. I think if you pass a Turing test, you count as artificial intelligence. Most of what we're talking about is really things like machine learning or, automated data interpretation or something like that. But anyway, artificial intelligence, AI, certainly all the buzzword these days. So we have to talk about AI, got to talk about artificial intelligence. What we're really talking about is massive parallelism. And again, PCI Express makes an excellent interconnect when you put a lot of different devices hooked together. All the traditional places in servers, and automotive is really kind of a new thing for PCI Express. What's interesting to me about automotive is when we look at automotive, what we're actually seeing is that exact same machine learning, massive parallelism. Back when I didn't have so much gray hair, automotive meant engine controllers, maybe some sensors for things like seatbelts, maybe ABS, something like that. Nowadays, when we talk about automotive, we're really talking about processing large streams of data from cameras, radar, sonar, LiDAR, whatever your R sensor of the week is. And we've added features to PCI Express over time to account for those types of things. Ethernet did their time-sensitive networking. PCI Express, we have precision time measurement. Because it's kind of important when you look at your automotive system, there's a big difference between the sensor saying there's a tree on the front and now the tree is off to the side, than there was a tree on the side and now it's in front. Kind of an important distinction. So we've added features to the spec over the years to account for that type of thing. And then storage. When we talk about the evolution of PCI Express speeds, storage has been one of the primary drivers for that because the storage form factors are limited in the number of lanes. We don't have enough time today to go through all the basics of PCI Express, but it scales outward based on number of lanes, and it scales upwards based on the link speed. So when you have a form factor that has a fixed number of lanes, and you have an increased bandwidth desire, that turns into one of the drivers for faster and faster speeds. I said that the graph with the purple on it was my mea culpa slide, and those of you who've been following PCI Express for some time know that it took us quite a long time to get the PCI Express 4.0 spec out. It is, however, now out. It's been fully released for over a year, and adoption is well underway. If you walk back out into the expo hall, you'll see quite a number of folks exhibiting PCI Express. And, excuse me, usually you have to go find the hardware guy, right? But ask the hardware guy, hey, is this PCI Express 3.0, 4.0? And more you'll find that they'll tell you it is 4.0. We're delivering 16 gigatransfers per second. Since it's the early morning session and you guys are, only half awake, I'll tell you an entertaining story. All right, it's only an entertaining story if you're a geek, but that's me. People ask me all the time, they say, Richard, why on earth do you guys say gigatransfers per second? And I say, because everybody hates it. It's true. So when we first did PCI Express, we looked at it, and all the digital guys like me said, oh, It's 2.5 gigabits per second. We would clock that digitally with a clock that runs at 2.5 gigahertz. It's a 2.5 gigahertz bus. Woohoo! Great. Well, then we get these analog folks. The analog guys looked at it and they said, what are you talking about, 2.5 gigahertz? If I look at the bits on the wire as a waveform, the frequency of that waveform is 1.25 gigahertz. It's not a 2.5 gigahertz bus. We said, okay, fine. How about we call it 2.5 gigabits per second? That'll make everybody happy. Well, then some bright-eyed, bushy-tailed young engineer looked at it and he said, you guys do encoding, right? Yeah, we do 8B, 10B encoding. So every transition on the wire isn't an actual bit. It's 8/10 of a bit. All right, we'll call it a transfer per second. The analog guys hate it. The digital guys hate it. It's perfect. So that's why when you see all these PCI Express presentations from the PCI-SIG, we talk about gigatransfers per second. Are you now absolutely solidly asleep where you weren't before? All right, good. I can't make the other joke about the drugs and the donuts because we're on video here, so pretend we had donuts in the back. And amongst the other changes we made to PCI Express 4.0, beyond the speed up, were some changes to the protocol itself. We expanded the number of tag bits that we offered. We expanded the number of credits that were available. This gave us the ability to get more transactions outstanding on the bus, and we did it with a mind to future expansion. So even when we were doing PCI Express 4.0, we had in mind that we would be bumping the speed again and again and again. And when I talk about PCI Express 5.0, one of the things I get to say, and we pat ourselves on the back for, is those scalings have proven to be adequate for PCI Express 5.0 as well. So there's no protocol changes necessary to handle the increased speed. The other big news on PCI Express 4.0 is our compliance program. And actually, I'll be back this afternoon talking with some other folks from OCP about OCP's movement into the compliance field. One of the things PCI-SIG offers is something we call the integrators list. And that is a list that's maintained online of devices that have passed our compliance testing. Another benefit to members, everybody who's a PCI Express member, which most of you should be, shows up, brings their device, we test it. It's a combination of interop testing and some what we call gold suite testing, or kind of basic parameter testing that we do. That program has been in operation. We started in early 2017 working on the PCI Express 4.0 16 gig testing. We've now progressed to the point where last December, we started our official FYI testing period. And the FYI testing period is important because it's a fairness mechanism, right? It makes sure that when you show up with your device in August, which is when we hope to start our formal integrators list testing, we don't say something like, oh, hi, Olga. Glad you could bring your device. We added this new test yesterday. You fail. So we have this 6-month period where all the tests are evaluated, and it gives everyone a chance both to test their device and to test our tests, right? Make sure we didn't mess up one of the tests. Make sure there isn't something wrong with that. So that process is well underway. We've had more than 50 participants so far. Actually, I think that's also probably really conservative. We've had more than 50, I think, at the last workshop alone. And I already mentioned, if you go look in the exhibit hall, there's lots and lots of PCI Express 4.0 devices out. Lots of companies talking about that. We've seen some big server and CPU vendors announcing recently as well. So PCI Express 5.0, the next generation. Now this one was really a tough one for me because I spend a fair bit of my time talking at conferences and talking to press and analysts, and they said almost universally the same thing. They said, Richard, it took you guys, what, 6 years, 7 years to get PCI Express 4.0 out? Remember your purple thing with the dot way off on this side? Yeah, I remember that. How do you expect us to believe you're going to do PCI Express 5.0 in 18 months? What are you smoking and where do we get some of it? And I said, no, really, honestly, it's going to be good. And I already mentioned, right, we did that tag expansion, we did the credit expansion. So from a protocol side, we already had the hard work done. What was left really for PCI Express 5.0, much as it pains me to admit this as a digital guy at heart, it's on the analog side, right? It was the PHY, the actual electrical interface, that became the challenge for PCI Express 5.0. And we could focus on that. Okay, it took us a little longer than 18 months. It's really been closer to 2 years. But the main thing here is we've released what we call the 0.9 draft of the spec. And I should take a quick aside to tell those of you who aren't familiar with PCI-SIG and our spec development process, just the 30-second version of this PCI-SIG spec development process. We start out with what we call a draft 0.3, which is the early version, just the concept of the spec. We move it through 0.5, 0.7 as we develop the methods. And as a PCI-SIG member, everyone is able to participate in that. So when we put out the 0.3 draft of the PCI Express 5.0 spec, it really wasn't much at all. It said basically, we're going to double the data rate. But if someone had had an objection to that, that was an opportunity for any member company to chime in and say, we don't think double's enough. You're way too late. You should go with quadruple or triple or 2.75 or whatever. So what that takes us to is when we get to the 0.9 draft, that is the final revision of the spec. There are no functional changes allowed after the 0.9. 0.9 is strictly out there as an IP review. So every PCI-SIG member company can look at the spec, make sure they're willing to license under the RAND terms, anything that they find in that spec that they might have IP around. So what that really means is, while we are on a about day-to-day step on getting the final version of the spec out as we fight it through the tech writers, and we're literally on the dotting I's, crossing T's, fixing up cross-references kind of level. As we get that spec through its very last stages to the final publication version, we've got member companies that have been executing since November, actually some even before then if they wanted to be speculative about it, who are delivering PCI Express 5.0. And as a coincidence, which I swear by all that is holy, I had nothing to do with and was not planned at all, it turns out that my employer actually is demonstrating the PCI Express 5.0 in another company's booth out in the exhibit hall. So I won't name names, but if you go look in the far corner, you'll see some folks that have a PCI Express 5.0 PHY showing the eye. So it really is real, it really is here, and the industry is clearly executing to PCI Express 5.0. There's another large manufacturer, I understand, was out here yesterday morning talking about their use of PCI Express 5.0 as well. So it's definitely out. There's full backwards compatibility. We've talked about the protocol already, the electrical being the main challenge. The other thing I should mention, you may hear people say, oh, there's a different connector for PCI Express 5.0. Well, that's technically true, and I'm not a signal integrity guy, so I can't tell you all the details, but when we looked at the connector, in order to make it run comfortably at 32 gig, we had to narrow some of the fingers, tighten up the stubs, a bunch of mechanical changes to increase the signal integrity. It is fully backwards compatible. You grab a PCI Express card from, 10 years ago, it'll plug into the new PCI Express 5.0 connector, work just fine. Likewise, if you build a PCI Express 5.0 card, you can plug it into that 10, 12-year-old PCI Express system, it'll work just fine. Again, if you look at the OCP project, it's that kind of backwards compatibility that makes PCI Express attractive, because you don't have to tear up your whole infrastructure every time somebody comes out with a new widget. Oh, look, I've got a slide on the benefits of using PCIe and HPC. All right, what didn't I already tell you? We talked about speed, we talked about backwards compatibility. I didn't talk to you much about the data integrity. PCI Express has a full suite of data protection that's built into the protocol, and almost all of it happens at a hardware autonomous level. So if you're building the greatest new AI widget, see how I sneaked in the AI mention there? And you want to move a lot of data, what you want to do is you want to focus on how you process the data and how you move it. You don't want to spend a lot of time dealing with protocol. At the PCI Express interface level, you just provide the data to the PCI Express controller, and it will get to the other end of the wire. There's LCRC that protects every packet. There's a replay buffer that takes care of lost packets or corrupted packets. All that stuff gets done at a hardware level. Your application doesn't even have to mess with it. We've also put in a lot of effort on I/O virtualization, a number of different specifications around that within PCI Express, and a number of mechanisms that we built for that folks are finding new and creative ways to do virtualization beyond what we've envisioned. Actually, most of this I talked about in terms of the transaction protections. There's also some kind of upper level checks that make sure that data is not lost. I got a really good joke I tell about that, but I'm running out of time, so you'll have to catch me on the side. And if you're still awake, I'll tell you the joke on how we deal with ACNAC timeouts. Oh, the last thing I'll mention on this is PCI Express allows, remember early on I mentioned that you can scale by width and you can scale by speed. So it allows you to change that both for performance reasons. So if you want to save power or cut down on noise, whatever, you can make the change. The links will automatically do that if there are signal integrity problems. So it'll degrade to a narrower width or at a lower speed if the link is having trouble. I think the last thing I've got here is lane margining is a feature that we added to PCI Express 4.0. This is something that's built into every PCI Express 4.0 device. At a very high level, what it does is it allows you to get through software a report back on the margin that's available for your signal eye. So you can actually find out that there's, 0.2 UI to the left and 0.3 UI to the right of the center point on your signaling. And this is useful for places like high performance computing where you care about reliability and uptime. It's useful for manufacturing where folks want to be able to go in and check the integrity of their system, things like that. And that's a standard part of all PCI Express 4.0 and beyond. The gentleman who introduced me talked about all the places where OCP is already using things, so I won't spend time talking about the different form factors. Several of those are also on display. With that, I will end. Tell you thank you very much for those of you who woke up and came out at 8 o'clock in the morning. I will certainly be around for the next few hours. I'm happy to answer questions. I could talk for hours on PCI Express and bore you absolutely to tears. So once again, thank you very much.